So hello everybody, this is Sandhya Rani. In this video, I would like to discuss about finite differences in interpolation. Okay, so let us see what are these finite differences. In this finite differences, we have three different kinds of finite differences. Very first one is forward differences, second one is backward differences, third one is central differences. So first, let us understand what are forward differences. So let us understand this forward differences by using a forward difference table. Okay, so this in as we have discussed in previous videos, the interpolation is nothing but the two characteristics will be there whose respective values will be given, and we are supposed to find out the value of the second variable with respect to the first variable, which doesn't exist exactly in the given information. So the process of calculating that unknown value is nothing but interpolation. So here the two characteristics, the two variables are given as x and f. Okay, they're given as x and f. So x values are all x0, x1, x2, x3, x4. Their corresponding f values are f0, f1, f2, f3, and f4. So here in this forward differences, we are going to have many forward differences. Among them, very first one is called as first forward difference. That is delta f. Means here the forward operator is denoted with a delta. This is called as delta and symbolized with a symbol triangle. And immediately the second forward difference and next third forward differences, next fourth forward differences, similarly fifth and sixth, so on. It will be continued until we have values for the differences. So let us see. First forward differences are all delta f0, delta f1, delta f2, and delta f3. Where this delta f1 is nothing but difference between f1 and f0, like this. Similarly, the delta f1 is defined as the difference between f2 and f1, like this. And delta f2 is nothing but difference between f3 and f2. Delta f3 is nothing but the difference between f4 and f3. So in this way, we can calculate first forward differences. Second forward differences are delta f0, delta f1, delta f2. What does this delta square f0 mean? The difference between delta f1 and delta f0 is nothing but delta square f0. The difference between delta f2 and delta f1 is delta square f1. And the difference between delta f3 and delta f2 is delta square f2. So like this, we can calculate third forward differences also. So what are third forward differences? Delta cube f0 to delta cube f1. So delta square f1 minus delta square f0 is defined as delta cube f0. Delta square f2 minus delta square f1 is defined as delta cube f1. Okay. And fourth forward difference is delta power 4 f0. That is nothing but the difference between delta cube f1 and delta cube f0. So like this, the differences, forward differences, like first forward difference and second forward difference, third forward difference, fourth forward differences, and so on will be calculated by using this forward difference table. And the forward operator is denoted with the delta. Okay, so now let us see backward differences. Again, in the same way of this forward differences, we are going to learn about backward differences by using backward difference table. So in this table, we have considered again two variables x and y. So all x values are what? x0, x1, x2, x3, x4, and x5. Their corresponding y values are all y0, y1, y2, y3, y4, and y5. Okay, so here also we are going to have multiple backward differences which are denoted with delta y nabla. Here the backward difference operator is nabla, and it is symbolized with the reverse triangle, nabla. Okay, second backward differences, nabla square y. Third backward differences, nabla cube y. Fourth backward differences, nabla power 4 y. And fifth backward differences, nabla power 5 y. So what are the first backward differences? nabla y1, nabla y2, nabla y3, nabla y4, nabla y5. When we have the y values as y0, y1, y2, y3, y4, and y5. So what are these differences mean? Y1 minus y0 is nothing but nabla y1. Y2 minus y1 is nothing but nabla y2. Y3 minus y2 is nothing but nabla y3. Y4 minus y3 is nothing but nabla y4. Y5 minus y4 is nothing but nabla y5. Okay. So similarly again, the next backward of differences are nabla square y2, nabla square y3, nabla square y4, nabla square y5. So how these second forward differences are defined as nabla y2 minus nabla y1, nabla y3 minus nabla y2, that is nabla square y3. And next nabla y4 minus nabla y3 is nothing but nabla square y4. Next nabla y5 minus nabla y4 is nabla square y5. Thereafter again third backward differences, nabla cube by 4, nabla cube by 4, nabla cube by 3, nabla cube by 4, nabla cube by 5, which are defined as the difference between nabla square by 3 and nabla square by 2. And here this nabla cube by 4 is defined as the difference between nabla square by 4 and nabla square by 3. And nabla cube by 5 is defined as nabla square by 5 minus nabla square by 4. So in the same way, the fourth backward operators, nabla power 4 by 4, nabla power 4 by 5, and fifth one also nabla power 5 by 5, which are nothing but the difference between nabla cube by 4 and by 3. Nabla cube by 5 and by 4 is nothing but nabla power 4 by 5. So nabla power 5 by 5 is nothing but the difference between nabla power 4 by 5 and nabla power 4 by 4. So like this we can calculate all backward differences. So where this one we are naming it as first backward differences. These are second backward differences, and these are third backward differences, and these are fourth backward differences, and these are fifth backward differences. Okay, so like this, after understanding about this backward differences, let us discuss about central difference. One more is there central differences. What are these central differences mean? In the same procedure, the x values are x0, x1, x2, x3, x4, and x5. They have given x1, x2, x3, x4, x4, x5. The corresponding y values are y0, y1, y2, y3, y4, and y5. So here also, here the central difference operator is again the S delta. This is called as S delta. Okay, right. So now let us discuss about the operators. First, central operators. What are central? First central operator, S delta 1 by S delta y 1 by 2, S delta y 3 by 2, S delta y 5 by 2, S delta y 7 by 2, S delta y 9 by 2. Where this suffices if you observe like 1 by 2, 3 by 2 are obtained as an average of this 0 and 1. Means y1 minus y0 is nothing but S delta y1 by 2. And y2 minus y1 is S delta y3 by 2. So here we are conducting a difference between y2 and y1. This suffices. Average is nothing but 3 by 2. That should be written here. Okay. Similarly, y3 minus y2 is nothing but S delta y5 by 4, 5 by 2. Next difference between y4 and y3 is S delta 7 by 2. The difference between y5 and y4 is S delta y9 by 2. So like this, we need to find out first central differences. Next is second central differences. Okay, delta square y1, delta square y2, delta square y3, delta square y4. Difference between these two is delta square y1. Difference between delta y5 by 2 and delta 3 by 2 is delta square y2. And next difference between delta y7 by 2 and delta y5 by 2 is delta square y3. And next delta 9 by 2, delta y9 by 2, and delta y7 by 2 is nothing but delta square y4. So these are second backward central differences. And next third central differences are delta cube by 3 by 2, delta cube by 5 by 2, delta cube by 7 by 2. The difference between delta square by 2 and delta square by 1 is delta cube by 3 by 2. The difference between delta square by 3 and delta square by 2 is delta cube by 5 by 2. The difference between delta square by 4 and delta square by 3 is delta cube by 7 by 2. So after this third central differences, fourth central differences. Delta power 4 by 2, delta power 4 by 3. Difference between the delta cube by 5 by 2, delta cube by 3 by 2 is delta power 4 by 2. The difference between delta cube by 7 by 2 and delta cube by 5 by 2 is delta power 4 by 3. Okay. So thereafter, fifth operator. Fifth central difference, that is delta power 5 by 2, means difference between delta power 4 by 3 and delta power 4 by 2 is nothing but delta power 5 by 2. And here one more new point is, when we are calculating these differences, the suffices average will be considered as suffix of difference operator. So like this, with the help of this central difference table, we can understand many central differences, like first central differences, second central differences, third central differences, fourth central differences, fifth central differences. Okay. So with this, we completed finite differences. With this, we completed finite